Hello students, welcome back to my YouTube channel Chemistry Pocket. I am your chemistry mentor Sreelatha. In this video I am going to explain Lewis dot structure. Now let's start the class. So Lewis is a scientist who put a step forward to explain the stability of atoms. To explain the stability of atoms he considered zero group elements. So what are the zero group elements? The elements are helium, neon, argon, krypton, xenon and radon. So to explain the stability of atoms, he considered the zero group elements. And here, zero group elements are participating in very few reactions only under certain conditions. It is nothing but these are highly stable in nature. Why these are stable in nature means these elements contains 8 electrons in their valence shell. That means behind the highly stability of these elements, we have one reason, that is these elements contains 8 electrons in their valence shell. The general electronic configuration of these elements is ns2 np6 except helium. Here helium is having the electronic configuration as 1s2 even though it is more stable in nature. Okay. It is nothing but the zero group elements contains 8 electrons in their valence shell. So based on that, he proposed a rule, that octet rule. The element which is having 8 electrons in their valence shell, it is most stable. It is nothing but when he observed the zero group elements, these are highly stable in nature. What is the reason behind this means? Because of having of an 8 electrons in their valence shell. This is the reason he found to explain the stability of atoms. So what is the mean by an octet rule? Let's see here. So this is an octet rule. So atoms are most stable when their valence shell are filled with 8 electrons. If any element contains 8 electrons in their valence shell, those are most stable. So this is the conclusion given by the Lewis and by proposing of an octet rule. And what about the remaining elements? The remaining elements are not having 8 electrons in their valence shell. So they are trying to get 8 electrons. How they are getting 8 electrons means by losing, gaining or sharing of electrons. So, and Lewis proposed a simple notation to represent the valence shell electrons of an atom, that is called as a Lewis symbols. Now let's see the Lewis symbol. That is nothing but the atom which does not contains 8 electrons in their valence shell, it is trying to get 8 electrons. So first of all I have to know how many number of electrons that atom contains. Okay, to know that, the Lewis explains the representation of a valence electrons through the Lewis symbols. So in Lewis symbols, first let us take lithium. So lithium atomic number is 3 and the electronic configuration is 1s2 2s1. It is nothing but lithium contains 1 electron in its valence shell. To represent that valence shell electron of lithium, we have to write lithium and only 1 electron. So we can put a simple dot, 1 dot around a lithium atom. This is called the Lewis symbol of lithium. Next take one more element as beryllium. So beryllium atomic number is 4 and the electronic configuration is 1s2 2s2. Okay. And how we can represent the Lewis symbol means beryllium. And how many number of valence electrons are there? 2. So we can write 1 and 2. Here the first shell electrons are called as core electrons or inner shell electrons. Next take carbon. So carbon atomic number is 6. 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. It is nothing but how many number of valence electrons are there here? 4 valence electrons. So write the carbon and write 4 valence electrons or 4 dots around the carbon atom. So in this way we can represent the Lewis symbols. That means number of valence electrons through symbols, or this can also be called as a Lewis dot structure. Now let us see the Lewis dot structure for molecules and ions. Here we have the simple steps to draw the Lewis diagrams or Lewis dot structure for molecules or ions. Now let's see the steps. So let us see the steps for drawing a Lewis diagram for molecules or ions. Molecules and also ions. So first, what is the first step? Count all the valence electrons. Next, the second step is determining of an central atom. And the third step is drawing of single bonds around the central atom. And the fourth step is putting of the remaining valence electrons as lone pairs on each and every atom. And the fifth step is turn lone pairs into double bonds or triple bonds to get octet of an each and every each atom. Okay, so these are the 5 steps which are involved in drawing of an Lewis diagram for molecules and also ions. Now let's take an example. So with an example I am going to explain how we can draw the Lewis diagram for molecules and ions. First take nitrite ion as an example. Nitrite ion. So example is nitrite ion. So in this example, first what is the first step? Count all the valence electrons. Counting of an all valence electrons. So nitrogen contains, so nitrogen is an 50th group element. So it contains 5 valence electrons, or we can say that it is an 15th group element. Okay. Next oxygen. So oxygen contains 6 valence electrons, and how many number of oxygen atoms are there here? 2. So 6 to 12. So total number of valence electrons are 17, and here negative charge is there, so we have to count one more electron. So total number of valence electrons are 8. So valence electrons are 18, valence number of electrons are 18. Next, what is the second step? So counting of valence electrons are finished. Next one is determine the central atom. So in this one, in nitrite ion, the central atom is nitrogen. Next, what is the third step? Draw single bonds to the central atom. Drawing of a single bonds to the central atom. So the valence, central atom is nitrogen, and nitrogen contains 2 oxygen atoms around it. We can draw like this. Okay. Next, drawing of a single bonds to the central atom. Next, what is the fourth step? Put all the remaining valence electrons on as lone pairs. So now I have to put all the remaining valence electrons as lone pairs. Here already 4 electrons are finished. So 18 minus 4 is nothing but the remaining valence electrons are 14 electrons. Now we have to arrange these 14 electrons as lone pairs in this structure. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remaining 4 electrons are there. So 11, 12, 13 and 14. Next, last step is turn lone pairs into double or triple bonds to give every atom an octet. So now here turn any one of the lone pair of oxygen as a double bond to give octet of each and every atom. Now I am turning these electrons as a bond pairs. Now let us see the structure of this molecule becomes as nitrogen, oxygen, single bonds. Next, this oxygen is forming a double bond with nitrogen, and how many number of lone pairs it is having? 1, 2, 3, 4, and this atom contains 1, 2, 3, 4, 5, 6, and nitrogen contains 2 lone pair electrons. Now count the total number of electrons are 18 is there or not? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So this is the Lewis dot structure for nitrite ion, and this nitrite ion is having a negative charge, so we can indicate that negative charge like this. And how many number of lone pairs are there? Lone pairs are 1, 2, 3. Here we can write the lone pairs. Lone pairs equals to 1, 2, 3, 4, 5, 6. So 6 lone pairs. And bond pairs, how many number of bond pairs? 1, 2, 3 bond pairs are there. So lone pairs are 6 and the bond pairs are 3. Okay. Next, let us see the one more example. Now let us see the Lewis diagram for nitrate ion. So nitrate ion is NO3 minus. So what is the first step? So count all the valential electrons. So nitrogen contains 5 and oxygen contains 6. 6 3 is 18. So totally 23 electrons, and negative charge is there, so we have to add that electron also. So total number of valence electrons are 24 electrons. Now in the second step, what is the second step? Second step is determining the central atom. So in this nitrate ion, the central atom is nitrogen. So nitrogen. Next, draw single bonds to the around the central atom. single bond oxygen, and also single bond oxygen, and also single bond oxygen. Next, what is the fourth step? Put all the remaining valence electrons on atoms as lone pairs. So oxygen contains totally 24 electrons are there. In the 24 electrons, 6 electrons are finished. So minus 6 is nothing but 18 electrons. The remaining 18 electrons are 18 electrons. Now I have to arrange these 18 electrons as lone pairs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 13, 14, 15, 16, 17 and 18. That means each oxygen atom is carrying 3 lone pair of electrons. Now what is the fourth step? So put all the, fifth step is turn lone pair electrons into double bonds or triple bonds to give every atom an octet. See here, nitrogen is nitrogen is having 8 electrons in their valence shell or not? We have to check it. So nitrogen 1, 2, 3, 4, 5, 6. So nitrogen is having a deficiency of 2 electrons. And what about oxygen? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Here also 8 and here also 8. So now we have to convert any one of the lone pairs in as a double bond in between the oxygen and nitrogen to give an octet to every atom. Now I am converting this lone pair of electrons as a double bond. So now draw the structure. Nitrogen, double bond oxygen, single bond oxygen and also single bond oxygen. So here this oxygen atom contains 2 lone pairs and this oxygen atom contains 3 lone pairs and it is also contains 3 lone pairs. Now count the number of electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So total number of electrons are 24. So this contains a negative charge. So we can represent the negative charge like this. Okay. And now we can write the number of bond pairs and also number of lone pairs. So how many number of lone pairs are there here? Lone pairs equals to 1, 2, 3, 4, 5, 6, 7, 8. 8 lone pairs and bond pairs are 1, 2, 3, 4. So 4 bond pairs are there. 8 lone pairs and 4 bond pairs. So now let's see the one more example as carbon dioxide. CO molecule, carbon monoxide. CO molecule. So in this CO molecule, what is in central atom? Carbon. First we have to count the valence shell electrons. So carbon is having of a 4 valence electrons, oxygen is 6, so totally 10 valence electrons are there. So what is the next step? Finding of a central atom. So here there is no central atom, just carbon and oxygen is there. Carbon and oxygen. So we have to draw a single line. CO. Next we have to write 2 electrons are finished. So minus 2 is nothing but 8 electrons. I have to arrange these 8 electrons as a lone pairs. 1, 2, 3, 4, 5, 6, 7, 8. Okay.